Welcome back. This is another Laplace functional and operational transform problem. Dealing with the two tables we have in chapter 12, designed to get you familiar with these two kinds of transformation operations, functional and operational. So we're asked to find Laplace of the third derivative with respect to time of t squared. Okay, I'm going to be honest with you for a change. No, I'm always honest with you guys, mostly. I couldn't get the right answer on this, but I got really close, and I'd like you guys to figure it out. So I'm going to go right up to where I couldn't do it. So anyway, let's let f of t equal t squared. So this is first method, method 1. All right. You do this thing. So if that's the case, then we're going to need these derivatives later, so let's do them. So f prime of t is 2t, right? I mean, I checked that a zillion times. And then f double prime of t is just 2. Yeah? Okay, so I don't think that's wrong. So then, Laplace of f of t is Laplace of t squared. Okay, now this is just 2 over s cubed. Okay, this I found on a table online. And I think it's right. But you could also integrate and see what you get. Okay, so or integrate yourself if you want to double check that. Anyway, let's call that big F of S, right? So then we have this rule in the table that d cubed over dt, or the third derivative of a function. Okay, we have this general form rule in table 12.2, and it's a real bear. But if you squint and look at it real closely, what it's telling you is you start with the top. We start with 3. And then you do big F of S, and then you start subtracting down like thus, whilst at the same time derivating up this way until you get to this noise. So this is what the general form used to go 3, 2, 1, 0 on the S's. You go F of S, big F of S, F 0, F prime 0, F double prime 0, like that. Pretty sure that's right too. So we're going to need these, right? F of 0 minus is 0, right? F of, where's that? Here it is. 0 squared is 0, right? And F prime at 0 minus is 2 times 0. It's also 0. And F double prime at 0 minus. Okay, now here, they're saying 0 minus. So these Laplace things are only defined, they're one-sided Laplace things. Oops, they're only this t. They're only defined. They only work after 0. There's like a step function implied. U of t is implied kind of everywhere. So if you use over here, it's going to be 0, but if you use on the other side of, it's going to be 2. I think. So this is, I'm not exactly sure on that. But anyway, we can plug in the F's and S's now on this thing. So this thing is s cubed and f of s is 2 over s cubed. This big f of s. I'm just plugging in this thing here with these things and this. So this is minus s squared f at f of 0. This one, 0. It's just times 0. And then this one is s times f prime at 0, which is 0. I know this is 0. These guys are 0 on both sides of 0. I know for sure these two are 0. I'm sure about these guys. I'm sure about this one. I'm sure about this one here. I'm not sure. Then this one, the last one, f double prime 0. I guess it's 0, because then that would give the answer in the book. Must be 0, because then that gives you 2, which is the answer in the book. I mean, that was easy, right? Because this cancels that, and these are all 0. Yeah, I don't know. I guess that's it. I don't know why I was having trouble with that earlier. Anyway, that's the answer, I guess. Although it does make me kind of nervous that it's like that. It seems like, but it wouldn't be 0, right? The Laplace of this, maybe it is. I don't know. I'm not a math teacher. It's my excuse. I just want to make circuits. I just want to build stuff. Okay, so method 2, we're going to differentiate first, and then we're going to transform. But if you guys have any insight into these things a little bit more than me, then put it in your homework. Send me an email separately if you want, because I would like to know. So let's see. So, oh yeah, here's where I had trouble. So the d cubed of dt, do this thing first. That's just 0, right? The cubic derivative of this is, it's 0. The third derivative is 0. It's like you get 2t, and you get 2t, then you get 2, and you get 0. That is the first derivative, second derivative, third derivative. So then I don't know what to do, because like Laplace of 0 is, I don't know. And I would get 0 over here if I use the 2. So, but the book says 2. So it should be 2. I don't know what to do. Anyway, let me know, okay? Yeah, if you haven't noticed, you soon will. I don't want to spend a super whole long time on this chapter, so the homeworks very, very closely follow what I'm doing in here, almost identically, if not identically. But let me know.